May 31st, 2013, 6:20 p.m. Reuter Road, Canadian County, Oklahoma. A Chevrolet Cobalt sits on a narrow dirt road, engine running, wipers fighting a losing battle against sheets of horizontal rain. Inside are three of the most experienced storm scientists alive. They have chased tornadoes for a combined 6 decades. They have never seen anything like what is about to happen to them. SFX radiostatic crackle, then a man's voice, calm but tight. "We're in a bad spot." SFX, sudden silence. Then a freight train roar swallows everything. The vehicle does not skid. It does not roll. It is lifted, whole, and hurled through the air like a child's toy, discarded by an angry god. 2 of the men inside are torn from their seats mid-flight. The third never leaves his seatbelt. He will be found exactly where he sat, half a mile from where the road used to matter. This was not a tornado that wandered into their path. This was a tornado that, in the span of minutes, grew wider than Manhattan is long, and then turned deliberately toward the only people on Earth foolish enough or brave enough to be looking directly at it. SFX, cut to black, silence. But to understand how 3 of the world's foremost tornado experts walked straight into the jaws of the widest tornado ever measured on this planet, we have to rewind. Not hours, days, because this storm did not begin on a road in Oklahoma. It began in the sky itself 11 days earlier, with a warning that the entire state was too exhausted to fully hear. Part 1. The week that wouldn't end. SFX. Soft ambient morning sounds, birds, a screen door, a lawnmower in the distance. 11 days before, on May 20th, an EF5 tornado had torn directly through Moore, Oklahoma, killing 24 people and flattening entire subdivisions into kindling. The state was still digging through rubble, funeral homes were still working overtime, and yet, by the final week of May, the atmosphere over the southern plains was loading itself again, like a weapon being quietly reloaded while no one had finished mourning the last shot fired. Meteorologists watched the data with a particular kind of dread. A dry line was sagging across central Oklahoma. Moisture was pooling at the surface, and aloft a jet of fast-moving air was about to slam into all of it, like a lit match dropped into a gas-soaked field. Atmospheric scientists have a number for this kind of explosive instability: CAPE, convective available potential energy. That week, values pushed past 4,000 joules per kilogram. To put that into something a human body can feel, it is the difference between a campfire and a fuel-air explosion. The sky was no longer storing energy. It was a bomb waiting for a single spark of wind shear to go off. By the morning of May 31st, the Storm Prediction Center had drawn a target on the map. Oklahoma City and the towns just west of it, Reno, Yukon, Mustang, sat inside what forecasters quietly call the bullseye. Locals didn't need a meteorology degree to feel it. The air itself felt wrong, heavy, charged. Old-timers would later say the sky had a strange greenish cast to it that afternoon, the kind of color that, in Oklahoma, people don't say out loud because saying it feels like inviting it. In Reno, a quiet town of 17,000, 30 miles west of Oklahoma City, Friday afternoon looked like any other Friday afternoon. Trucks idled at the Sonic Drive-In. Kids counted down the hours to summer vacation. A young mother loaded groceries into a minivan with her husband and 3 children, the youngest only 17 days old, completely unaware that within hours that vehicle would become the difference between life and death for everyone inside it. None of them knew that, 90 miles away, hundreds of trained storm chasers, meteorologists, scientists, hobbyists, YouTubers, and thrill seekers were already pointing their vehicles west. They had felt the same charge in the air. They were driving toward the one thing everyone else in Oklahoma was about to drive away from. Part 2. The birth of a monster. 5:37 p.m. The National Weather Service issues a tornado warning for a rapidly intensifying storm cell crawling along Interstate 40 in Canadian County. At this point, it is nothing extraordinary. A modest rotating supercell, the kind that spins up across Tornado Alley dozens of times a season. 6:03 p.m. 8 miles southwest of Reno, the rotation finally reaches the ground. A slender funnel touches down, narrow, almost delicate, rated no higher than EF1. For a few minutes, it behaves the way a tornado is supposed to behave: predictable, linear, survivable. Then it stops behaving. Within minutes, the tornado begins expanding at a rate that defies almost everything storm chasers have learned about how these things grow. It widens past a quarter mile, past half a mile, past a mile. Doppler radar units parked along nearby roads start returning numbers that, for a moment, the operators assume must be equipment error. They are not. The tornado swallows itself in rain, wrapping its own circulation in a curtain of water so dense that from outside it no longer looks like a tornado at all. It looks like a wall. A storm chaser cannot see the danger because the danger has disguised itself as the storm around it. The funnel and the rain become the same gray nothing, and inside that nothing, the wind is already exceeding 200 miles per hour. By the time it crosses Highway 81 south of Reno, mobile Doppler radar operated by University of Oklahoma, researchers capture something almost nobody believed possible: a tornado 2.6 miles wide. For scale, that is wider than the entire length of Central Park. A single rotating column of wind, vast enough to contain an entire town's worth of city blocks inside its outer wall alone, and people standing half a mile from its visible edge would have had no idea they were already standing inside it. The same radar clocks wind speeds inside the vortex at nearly 296 miles per hour, among the fastest winds ever measured on the surface of this planet. At that speed, wind does not simply knock things down. It does not destroy a house the way you imagine destruction. It erases. Asphalt is peeled directly off the roadway in sheets, like skin off a sunburn. Steel guardrails are torn from their concrete anchors and folded like ribbon. A vehicle caught in that wind is not blown off the road. It is picked up the way a hand lifts a leaf, weightless, directionless, gone. And this tornado was not finished growing. It was not finished moving. And it was not moving in a straight line. Part 3. The trap no one saw coming. What made the Reno tornado different from almost every other tornado in recorded history was not just its size, it was its mind, or what looked terrifyingly like one. Most tornadoes move in a single, mostly predictable direction, allowing trained chasers to position themselves at a safe distance, parallel to the storm, always with an escape route open behind them. This is the entire foundation of storm-chasing safety. Never let the tornado choose your road for you. Reno broke that rule by breaking the laws chasers thought governed tornado behavior. It began moving southeast. Then, with no warning visible on radar until it was already happening, it curved hard to the east. Then, and this is the turn that erased every escape route for dozens of vehicles strung along the highways below it. It suddenly swung north, accelerating to over 50 miles per hour, doubling its own forward speed in a matter of minutes. A tornado moving in a straight line is dangerous. A tornado that suddenly reverses its angle of attack while also widening to over 2 miles across is something closer to an ambush. Storm chasers who believed they were safely south of the circulation, watching from a respectful distance, looked up to realize the entire calculus had changed. The thing they thought they were observing from outside had quietly redrawn the battlefield to put them inside it. Embedded within the broader 2.5-mile circulation were smaller, faster subvortices, miniature tornadoes spinning within the larger one, like teeth inside a mouth, each one capable of producing localized winds even more extreme than the parent storm. One of these subvortices is what investigators believe struck the vehicles on Reuter Road. It would have been invisible until the instant it arrived. There would have been no countdown, no siren, just rain and then nothing but the sound itself. Along Interstate 40, the chaos compounded. Just 11 days after the trauma of Moore, residents who would normally shelter in place instead did the opposite. They got in their cars and ran. Schools and offices had let out early. Within minutes, the highways leading away from the storm's path locked into gridlock, a parking lot of fleeing vehicles directly beneath the widest tornado ever measured in the United States. Emergency officials would later call it one of the most dangerous traffic situations in the history of severe weather response in America. Thousands of people trapped in steel boxes, immobile, while a 2.5-mile wide engine of destruction bore down from the southwest. Part 4. The Last Transmission. Among the chasers converging on the storm that evening were 3 men with more tornado experience between them than almost anyone alive. Tim Samaras, a soft-spoken engineer who had spent over 2 decades pioneering the science of in-situ tornado measurement. His son, Paul, a young photographer who had grown up in the passenger seat of his father's chase vehicle, and Carl Young, a meteorologist who had taught extreme weather science for years before joining Tim's research team, TwistX, the tactical weather-instrumented sampling in tornadoes experiment. Tim's life's mission was placing scientific probes directly in a tornado's path, instruments that could record pressure drops and wind speeds from inside the vortex that no satellite or stationary radar could ever capture. He had done this safely, methodically, for over 20 years, using a reinforced, heavy-duty truck built specifically to withstand hail and high wind. But that evening, the team had split vehicles. Carl was driving a standard subcompact Chevrolet Cobalt, a car with 3 45-pound weather probes loaded into the trunk, but with none of the structural reinforcement of Tim's usual chase vehicle. Colleagues would later describe it, almost gently, as something closer to a pizza delivery car than a piece of scientific field equipment. As the tornado executed its violent northward turn, the team found themselves, for the first time in over 2 decades of chasing, with no usable escape route. Witnesses and audio recovered later captured the final seconds of calm professionalism, dissolving into the recognition of what was actually happening. "We're in a bad spot." It would be the last clearly understood phrase recovered from inside that vehicle. The Cobalt was lifted from the road and thrown roughly half a mile. Paul and Carl were ejected from the vehicle mid-flight, their bodies later found in a field, half a mile from the road, in opposite directions from one another. Tim was found still strapped into the passenger seat, the seatbelt undamaged, as though some part of him, in the very last second, had simply tried to hold on. They were the first storm chasers ever confirmed killed by the very tornado they were chasing, a tragedy that would permanently reshape the safety culture of an entire scientific field. Elsewhere along the same roads that evening, other lives were lost in eerily similar ways. A local rancher named Richard Henderson, untrained but drawn by the same magnetic curiosity that pulls thousands toward these storms every spring, had pulled over to photograph the funnel on his phone. He sent the image to a friend. Minutes later, the tornado reached him. A young family, a mother, father, and 3 children, including a newborn just 17 days old, were caught on Interstate 40 in their minivan. The mother had unbuckled her own seatbelt to comfort her crying infant in the back seat. When the tornado struck, she and her husband were ejected from the vehicle as it was hurled into a nearby field. Her husband and 2 of her children survived. She did not. Other chasers came within seconds of joining the death toll. A Weather Channel meteorologist's vehicle was lifted and rolled by the wind, leaving him and his crew injured but alive, pulled from the wreckage by a fellow storm chaser who happened to be driving past moments later, one of countless small, anonymous acts of rescue that played out across the dark, flooded roads of Canadian County that night. By the time the tornado finally lifted off the ground at 6:43 p.m., having carved a 16-mile path across the open farmland west of Oklahoma City, 8 people were dead and over 150 injured. The death toll, mercifully, was far lower than it could have been, almost entirely because the tornado's path crossed mostly open countryside rather than dense neighborhoods. Had this same storm tracked directly through central El Reno or the western edge of Oklahoma City at full width and full intensity, meteorologists would later admit, quietly, that the result would likely have been one of the deadliest tornado events in American history. Epilogue: What the Storm Left Behind. The deaths of Tim Samaras, Paul Samaras, and Carl Young sent a shock wave through the storm, chasing and meteorological communities that is still felt today. For decades, storm chasing had operated on an unspoken assumption. Experience and knowledge were a form of protection. Samaras was not a reckless amateur. He was, by every measure, one of the most careful, methodical scientists in the field. A man who had spent 20 years proving that tornadoes could be studied up close without anyone getting killed. El Reno proved that assumption wrong. In the aftermath, storm-chasing organizations and research teams rewrote their safety protocols, building in far larger safety margins, stricter escape route planning, and a cultural shift away from the kind of close-range pursuit that had defined the hobby for a generation. 2 days later, in a quiet tribute that would have meant something to men who spent their lives reading the sky from below, dozens of storm chasers across 3 states aligned their GPS-tracked vehicles to spell out the initials of the 3 men killed. A message visible only from above, written in the same open landscape where the storm that took them had been born. The El Reno tornado of May 31st, 2013, remains to this day the widest tornado ever measured on the surface of the Earth. It lasted only 40 minutes. The sky doesn't negotiate, doesn't warn twice, and doesn't care how many decades you have.